Alright, we're going to take a look at limits, and I'm going to have a series of videos on limits, and we're going to look at limits both numerically and graphically. And I'm going to kind of have layman's definition of a limit, and I'm going to do it numerically. When I talk about numerically, I'm going to talk about a table, and so I'm also going to show you what this is going to look like. So the first example is, and this is limit notation, and I want to make sure you write it in limit notation. LIM stands for limit, and it's limit as x approaches 2. Again, I say this is x approaches 2. Not what x is at 2, but what y is becoming as x approaches 2. And so what I'm going to do here is I'm going to put a function up here, and my function is going to be 2x plus 1. Alright, so the first thing I'm going to do is I'm going to create a table, and my table is going to be pretty standard from problem to problem. And it's going to have 2 rows. And the first row is going to be my x value, and my second row is going to be my function f of x, which in this case is 2x plus 1. Now I won't always write 2x plus 1, but I am in this case to illustrate it. And I'm going to, in the very middle, put 2. And to the right of 2, I'm going to put 3 values. And those 3 values are values that are going to be bigger than 2, and they're going to be values that are approaching 2 from the right-hand side, from the bigger value of 2. So graphically, it's going to look like this. Let me draw a y-axis and an x-axis. Right here is, I'll put 1 right here. Right here I have 2. Right here I have 3. So here's my x values. And I have the equation 2x plus 1, which means it has a y-intercept of 1 and a slope of 2. And so my graph, let's see, I'm going to draw it like this, I believe. There's a line that passes through in such fashion. So right here, is my y value for 2. And the values I'm going to put here are values that are x values that are approaching 2 from the right. So they're going to be very close to 2, but they're going to be bigger than 2. So the first one I'm going to put here is 2.1, because that's furthest to the right. 2.01, now I'm moving left from the right-hand side of 2, and I'm getting closer and closer to 2, but I'm not going to be 2. Alright? So if I plug 2.1 into this function, and consider that I'm going to have 2 times 2.1, which is 4.2, and if I add 1 to it, I'm going to get 5.2. If I point 2.01 in there, I'm going to have 4.02, and add 1, I'm going to get 5.02. And if I put 2.001 in there, I'm going to get 4.002. And when I add 1, I'm going to get 5.002. All right? So as I'm approaching from the right towards 2, I'm getting y values. And over here I have a y value called 5. I'm approaching 5. I'm just above 5, just barely above it, but that's what I'm approaching from the right. Now I'm going to do the same thing from the left-hand side. But this time I'm going to have numbers smaller. So I'm going to start out with 1.9, 1.99, 1.999. So again, they're very close to 2, but they're not 2. So if I put those values in there and I multiply it by 2 and add 1, I'm going to get 4.8. And then the next one I'm going to get 4.98. And this one I'm going to get 4.998. And again, I'm approaching this way. My x values are smaller than 2. But I'm approaching 2 here, and I'm going up here, and I'm getting y values that are just less than 5, but very close to 5. Okay? So as I approach 2 from both the left side and the right side, I'm approaching a value up here. Now, here's what you have to be careful of. I could put 2, substitute it in there, and get 5. But you have to be very careful because that's not the definition of a limit. The definition of a limit is what value, am I approaching as I approach this constant x from both the left side and the right side. And you can see these values that they're getting very close to 5, and my answer here is 5. When we take a look at the next problem, hopefully they'll illustrate that we get the same type of answer even though our graph looks slightly different.